Okay, this is LeetCode 206 reverse linked list. This is considered an easy question by LeetCode standards, but it's actually can get a little confusing if you're not familiar with it, but it's a pretty common question, um, especially for interviews, like internship interviews. So getting a good grasp of this is a good idea. So given a head of a singly linked list, reverse the list and return that reverse list. So this is going to be our head. Do this in red. See it? So this is going to be our head value, and then our next is going to be this value. So they want us to return it where this is our new head value down here, and then this is the rest of the list. So you can see that it's in reverse order because the given list was in ascending order. So it was 1, 2, 3, 4, 5, right? And then the returned was 5, 4, 3, 2, 1, and so forth, right? Okay, so let's go ahead and move this over slightly. Okay, so how are we going to do this? So I'm going to write out our linked list over here. 1, 2, 3, and I'm just going to cut it down to 4, so this is a smaller example. Okay, so what we're going to do is we're going to use some pointers. We're going to use our head value. We're going to assign that to current as well, but this is also just going to be our head value. And then we're going to have a previous, let me move this over slightly so there's a little bit of room. Previous, previous is going to be equal to none, which is basically Python's version of null. Okay, and then what we're going to do is we're going to move these links, or these links, these arrows stand for basically connections from one node to the other. So these are all nodes, right? And people signify them by using these little circles. So they're just called nodes with values inside of them. And this node has a connection to this first node right here has a connection to this node via this arrow, or a connection called next in the nodes class. Okay, so what we're going to do is we just want to reverse it so that it ends up looking like this. We're going to do it for every node so that our linked list is eventually reversed in order so that it's 4, 3, 2, 1, right? Alright, so how are we going to do this? So before we move any links, what we're going to do is we're going to just store this into like a temporary variable. What we're going to do is just say cur dot next is equal to previous, right? So this is going to flip this arrow to point that way. So now our new linked list is going to be 1 pointed to none, and then we're going to have 2 linked lists now because we've broken that connection, right? So this line breaks this link in between the 1 and the 2, but we still have access to it because we've stored it in the temp variable. Okay, and now what we're going to do is move our we're just going to move our pointers over, right? So what we're going to do is say let me do this in a different color. I'm not sure what color this is. Let's do it in yellow. Let's do it in white. We're going to say cur is equal to temp. Okay. And then, oh, and then before this, actually, we need to move our previous value. So this previous value needs to be moved over. So before this, we're going to do previous. Before we override our current value, we're going to say previous is equal to current. Okay, and then we just want to keep doing this process all the way until our current value is equal to none. At that point, we can stop our loop. So this condition is going to be in a while loop. So let's go ahead and just speed run this. So we're going to have none pointed to 1, and then eventually it's going to look like this. It's going to also look like this. We're just going to repeat all these steps, and then eventually our current value is going to be equal. It's going to be all the way over here, and it's going to be equal to none. And at that point, we can just stop our loop. Okay? So let's go ahead and write our pseudocode for this. So let's do it in this color, but yeah, that's fine. Okay, so we're going to say previous is equal to none, right? And then current is equal to our head value, because that's the value that's given in our input. As you can see, if we scroll in right here, that's the input value. Okay, and what we're going to do is, I'm going to separate this here. While current does not equal none. And I believe you can actually shorten this to just to say while current. But if you're not familiar with that syntax, you might as well say it explicitly, and just say while current is not equal to none. So while current is not equal to none, inside of this loop, we're going to say our temporary is equal to current dot next, right? And then we're going to say is we're going to do this step right here, where I'm writing the start. We're going to say current dot next, or in essence, we're just flipping the link. We're flipping the arrow. Dot next is equal to previous. Sorry for my phone going off. Previous. And then what we're going to do is now we want to move. We're going to do these steps right here where I'm drawing the star now. I'm going to draw the star in red so you can see. I don't think you can see my cursor unless I draw, so I'm going to do these steps now. Okay, and I'll do it in red so you can see. So we're going to say previous is equal to current. We're updating our pointers, and we need to make sure that we do this one before the next one, or else it'll mess up the algorithm. Because at this point, when we say current is equal to temporary, at this point, we've reassigned current, so then previous isn't going to be moved over once. Okay, so that's that part. And then what are we going to, they want us to return the head of the new list, right? So what we're going to do is, well, when our loop ends, current right here, current is going to be equal to none, right? This is going to happen when our loop ends. What can be our value that we're going to return? Well, that's going to happen to be previous is always going to be previous right here, previous is always going to be before current. So this is going to be our new head of the list. So we can just say return previous. Okay. And I believe that should be it. So let's go ahead and just swap over to LeetCode and type out this solution. Actually, before we do that, this is going to be, let's go ahead and do that time and space complexity. So time complexity is going to be big O. Let's do it in white. So time is going to be big O of n, where n is the size of the length of the linked list, and space is going to also just going to be O of 1. It's constant because the amount of space we're going to use is going to stay constant regardless of our input size. However, that's not the same for time. As our linked list grows, this algorithm is going to take a little bit longer to perform the calculation. So it's going to perform linearly. So if we have a size 100, it's going to be linearly to that input size and so forth at the time. Okay, let's go ahead and swap over to LeetCode and type this out. Alright, so we're in LeetCode now, and we have our whiteboard over here just for reference, but let me make this slightly bigger. Stop out so you can see a little easier. Okay, so let's type out what we have on the left. So I think we've pretty much done all of the work, so we're just going to type it out. So previous, we're going to initialize it to none. Current is going to be equal to head, and you know what, just because just to be more explicit, we're going to not previous head, we're going to create previous node, just to be a little more explicit as to what these values actually are, because you can get a little confused reading it later on. So you kind of want to be more explicit. So while current node does not equal none, or Python's version of null, basically, I'm going to say temporary node is equal to current node dot next. Okay, and then we're going to say current node, this is going to be our moving of the link. We're going to flip that arrow to being pointed left instead of right. Current dot next is equal to previous node. Okay, and then we're going to say previous node is equal to current node. Okay, because this is just moving our pointers of previous and current over. But first we need to make sure that line 14 happens before line 15. So we're going to say current node is equal to temporary node. Basically what I said earlier is that we need to make sure that we perform this operation before this operation, so that we only move the previous node and the current node once, or one position over. Okay, and then this should be fine for the loop, and then we can just return previous node. Yeah, so this is again big O of n time and big O of 1 space. Let's see, let's run this, see if we made any errors. Yeah, so that's that. This is reverse linked list. Thanks for watching.